next thing we look at is very similar to the previous. Is this set a subspace of R3? And this is just a set of x, y, z, such that ax plus by plus zz plus d equals 0. Okay, do these x, y, z's, these sets of three values, form a subspace of R3? Well, let's let x1, y1, z1 be in S. Then we ask, is gamma times x1, y1, z1 in S? Well, this says that ax1 plus by1 plus cz1 plus d equals 0. That is, if x1, y1, z1 is in this set, then this relationship has to hold. So we have this, ax1 plus by1 plus cz1 plus d equals 0. Well, gamma times x1, y1, z1 is in S if, and only if, a times gamma x1 plus b times gamma y1 plus c times gamma z1 is in D. Since this is gamma x1, gamma y1, gamma z1. Okay, well, that's how we start the proof. And then I have etc. Okay? Well, we already saw in the preceding example how this works out. You should be able to adapt it to this particular example. But I'll say even a little more. You can show that D would have different values unless D equals 0. And D can't have different values because D has only one value in the definition of your subspace. Now let me also say that we haven't proven in the previous example or in this example at that point that this is a subspace. We have to go on and prove, well, we have to prove what the problem states, and I'm not going to repeat that. It's very similar to what the previous problem said. And the whole thing about if and only if applies equally well in the way you have to follow up to prove the other part. Okay? Now, I'll say that there was one very clever or very interesting approach used by one student for this. So I'm going to talk about that briefly next.